how do we sort of define resiliency and why is that so important? I think, look, resiliency is a nice way of being able to say that you have access to the information you need when you need it to be able to do the job that you have. So no cyber issues, no governmental issues, that we're able to deploy wherever the customer needs us to deploy, and we're able to give them access to the system when they need it. Now, I feel like for the second part of the question that you're asking around industrial intelligence, I think bringing the data together is an important part of that, right? Making sure that we have access to all the right information and we bring that data together into context. It's critical, in fact, because one of the biggest challenges in the industry today is not having a structured data set. So all the AI and all the visualization and all the experiences that you could build won't provide the outcomes you expect if the data is not right. So it's there and it's important, and we need to focus on that, as well as making sure that the applications that we build on top of it are delivering value for customers. And when you combine the fact that you have trusted data and you have a capability that will allow you to run through a workflow that solves a problem, you end up with industrial intelligence, right? You can make decisions based on this data and you can trust it. If you look at machine design and then you also think, well, there's software associated with that, right? And there's the combination of those to add value for the end customer, I think, excuse me, can be quite significant. But I also think, we know where our software handles well the requirements of a discrete manufacturer, and we know where we have software that doesn't. So part of what we have to do is just try to make sure that we're evolving the things that work well and making sure that those continue to do a great job. And whether we infuse AI into those, we create the digital twin from those, that kind of thing, we focus, right, a little bit on that. When you talk about machines and machine builders, is it more of an OEM relationship where you've got machines that are being manufactured? Then I definitely think that onboarding software to that, to give the information from those machines to a central manufacturer, right, where they can start to do analysis across the board, right? So you're looking at by machine, but also by plant, by use case, maybe even by where the machine is, if it's outside or inside. You can start to do all this kind of analysis with that data. To me, having the data on board and the pipeline to a common place is, I think, instrumental for improvement, and improvement also in engineering, because some of that data will help you with re-engineering the machine. What I believe is that an individual can go look at an individual asset and make an assessment, right? But when you can combine the data across many of them, you start to see patterns that are a little bit different, and you can start to think about, okay, why did this fail here and not there, and come to those conclusions, sensor placement being one of them, but it also could be the way that the machine is actually built in the first place. So there can be some suggestions to build for reliability. And these OEMs, they can create a service that adds value to the customer because they can also make these recommendations, right? Because some of these manufacturers, they might not have the people to be able to do all the analysis. But companies like Schneider Electric, other companies like, that Tetra Pak, people like that, they understand their machine quite well. So when there needs to be a recommendation, providing the data to them, having them make the recommendation and then sending that back is really a core tenet of Connect, right? It's about taking the information, using it for why you have it in the first place, but then also extending the use cases for it so it becomes more valuable. Probably the most fastest growing around digital twins is going to be Europe, in my opinion, and then with the Americas after that. And I think a lot of that is just because of the amount of time that customers have had some of these tools. And I think that the other point maybe that needs to be made is that a digital twin isn't the same for everyone. So if you were looking at a food plant, they care about collecting data, showing that data, in a graph or a pie chart, being connected to an online system, things like that for their process, their packaging machines, their palletizers, all of that. Is very different than what a digital twin might look like from a refinery, where they absolutely 100% need access to the engineering data, right? So you've got that full engineering to operations digital twin, let's say in refining and in power, where they're a little bit further along in their maturity. I think it'll come for the other industries, but it's just not there yet, because a food plant might not, have the engineering data. So what we do in those cases is we say, okay, you don't have your original 3D models or you don't have that data, but we can do a laser scan of your plant. And that might be more efficient for a food plant to just have that laser scan as a way to actually visualize where you are in the plant in other use cases that we have. You use Netflix for years. It's all built on AI. No one cared. It was just Netflix, right? So I feel like it would be right now for the industry that we're in, right? AI is everywhere, as you said, right? It's plastered everywhere. And so we're doing that same thing. We're pointing out where we're using AI inside the design, the build, the operate, the optimize life cycle of an asset. And we're doing that because people expect to see where your AI is, so we're calling it out. But in the end, we've been doing it for 20 years. And I think when you go to the expo, you'll see it infused to both help an individual, like a persona that is trying to do a job, maybe make that more efficient. We've also created AI that's a little bit horizontal, so that like an advisor service that could be deployed in all of our applications. There'll be less and less horizontal AI and more deep domain use cases of AI, I think. A data science was a specialized skill, and it is, right? She actually already is a data scientist. So it is a specialized skill. But more and more people in the OT world, where we come from, right, where the plant, like you're talking about supervisors and things like that, they're going to become more attuned to being able to generate their own conclusions based on the data that they see. And so if we make it really easy for that process engineer or that operator to be able to experience the data in a new way and apply analytics without even knowing you're doing that, I think then you do get to the point that Artie's talking about, where they're not just necessarily turning a crank for a reason. They're saying, no, I understand that if I do this, I'll get that out of it. So it gives them more information, right? So they're still making the end choice. They're still making the end choice, but we have to turn the software into something that they can use. And it's not so much for the people at the end of their career, it's more for the people that are coming in that have a very different expectation of how they use software, right? And how they interact with it and what they'll expect it to do if they swipe left or, they do, they have a different expectation of the experience.